Okay, so we're looking at question 735, asteroid collision. It's a medium question, and let's get into it. So we're given an array of asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size, and the sign represents its direction, positive meaning right, negative meaning left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If two are the same size, both will explode. Two asteroids moving in the same direction will never meet. Okay, so let's look at the examples here. We're given an asteroids array, and 5 is moving in the right direction, 10 is moving in the right direction, so they both never collide. But then negative 5 is moving in the left direction, so 10 and negative 5 are going to collide. The bigger one out of the two, so 10 is greater than 5, so 10 destroys the 5, so 10 is left over, and 5 and 10 are going to be moving in the same direction and they'll never collide again, so the result is 5 and 10. Next example is 8 and negative 8. 8 is moving in the right direction, negative 8 is moving in the left direction. They're both the same size, so they both explode and our output is an empty array. Last one, we have 10, 2, and negative 5. 10 and 2 are moving in the right direction. Negative 5 is moving in the left direction. 2 and negative 5 collide because one is moving in the right, the other one is moving in the left direction. And 5 is greater than 2, so 5 destroys 2. And then 10, moving in the right direction, has to collide with negative 5, which is still moving in the left direction. And upon colliding, the 10 is left over, so we leave the 10 and destroy the 5. Okay, that makes sense. Let's get into the explanation of this problem and then go into solving the problem itself. Okay, so question 735, asteroid collision. There are a few key points that we should note before we actually get into solving the problem. The first one is that stacks are a good data structure to use in this problem. That's because you can pop the top value of a stack and then compare it to an incoming value. If an incoming value is positive, then you add it to the stack. You don't compare it with any value in the stack and just automatically put it in the stack. If the value at the top of the stack is negative and the incoming value is negative as well, then you add the incoming value to the stack. That's because both of them will never collide. The same thing happens with the second bullet point here. The positive, regardless of whatever's in there, is never going to collide with another one that's already in the stack. The fourth bullet point here is that if the value at the top of the stack is positive and the incoming value is negative, then you compare the values and perform required operations. The required operations here are in an event that, let's say, the value at the top of the stack is an 8, for instance, and the incoming value is an 8, you know that you need to destroy the two values. Or in an event that, let's say, you have one that's less than the other, then you either pop it or from the stack, or then you push it onto a stack. Okay, so let's get into some examples here. These are all the examples that were given to us in the problem statement itself. We're given an asteroid array or a list with 3 numbers, 5, 10, and negative 5. If we use the approach that I mentioned before, where we're using a stack, we know that when you loop through the asteroids, you have 5 come up first, so you add it onto the stack. Then you don't do anything, you move on to the next value, which is 10. And since 10 is positive, we mentioned that since 10 is positive, you add it onto a stack as well. Next, you have a negative 5. Now you compare negative 5 to the value in this at the top of the stack. If this value was a negative as well, then you would just automatically push it onto the stack. But since both of these values are different signs and the value in this top of the stack is a positive and the incoming value is a negative, we will compare the two values. So you can compare the top value, which is 10, to 5 and see which one's greater. In this case, 10 is greater, so we keep the 10 and we ignore the 5, right? And that's it. And then you just return the stack, and that's your answer. Because these values, nothing can happen between 5 and 10. They're moving in the right direction. Going on to the next example here, again, we're at a positive number, so we add it into the stack. Then again, we move on to the next value and we're at a positive value, so we add it onto the stack as well. And then we hit a -5. Now we compare -5 with the value inside the stack. We notice that 2 is in the stack, which is positive, and it's less than the 5. So we have to remove this value from the stack here, and we have to insert the 2 in there. Okay, so let's do that. Let's insert the -5 now, just to see what it looks like. So now we have -5 and 10, but we know that this -5 is moving in the left direction and the 10 is moving in the right direction, so they are going to collide. So you have to compare the two of these, and you can do this by actually not putting it in the stack instead. Sorry about that. So instead of actually putting it into the stack, so let's say we had the 2 still here, right? Now instead of you putting it into the stack after comparing it with 2, you would just pop this value off, and then you would loop and check the next value in this stack. So now you have a -5 on the side, you remove the 2. Now you compare the -5 with the 10 that's already in here. And upon comparing the two, you notice that the 10 is greater than the 5. And so you ignore this 5 and you keep the 10. In an event that, let's say, there was a 5 in here and a 10 outside, then you would pop this 10 out, or pop that 5 out and then put the 10 in instead. But you wouldn't put it in, you would compare every other value in the stack. And at the end of it, maybe you'll reach a point where the stack is empty. At that point, you can just put -5 in there. Okay, so that makes sense. We'll move on to actually writing the code to this problem now. Okay, so let's get into writing the code to this problem. I mentioned that we will be using a stack, so let's initialize our stack here. And then we also know that we will be looping through the values in Asteroid. So we can do something like for Asteroid and Asteroids. And yeah, so now we're going through every single value in the Asteroid that's given to us. And now for every value, we want to check the length of the stack, right? Because we want to make sure that there's at least one value inside of the stack. But we also want to make sure that the value in the asteroid that we just picked is less than 0, right? Because if it was positive, then we automatically put it into the stack. So it needs to be less than 0, and we need to make sure that the top of the stack is greater than 0 because it needs to be positive. Now, what kind of a loop will we be using here? It makes sense to just do a for loop or if loop, right? If statement here. But the issue is, what if you compare the inserting element to the one in the stack and you remove a value from the stack? Now you need to compare the value you're inserting again with the next value. So it'd be better if there was a loop instead. And so a good use would be to use the while loop here. And inside this while loop, we will have multiple statements. Now what happens if the while loop is not met? So in an event that the stack does not have one item, and if the asteroid was it was positive, or if the value in the stack was negative as well. Well, then you need to append it into the stack. So you do stack.append and append the asteroid into it. Okay, so what happens in an event that we do loop through this while loop? Now, there are different things that can happen. One is where the inserting element is equal to the value of at the top of the stack, right? So let's say stack if the stack at -1, which is the top of the stack, is equal to asteroid. Now we can compare it to asteroid, but we know that there's still that negative sign, right? So they're never actually going to be equal. Because one of them is going to be positive in this at the top of the stack, and the other one's going to be a negative that's coming in, and they're never actually going to be equal. So what we can do is we can do a negative of asteroid, and then we can compare it. Now, when two values are equal to each other, we need to make sure that both of them get destroyed. And we can do this by just popping the value from the stack, and we can break out of this while loop. And so we move on to the next value, next asteroid that comes in. The other case is where you're looking at the top of the stack again, but the top of the stack is greater than the asteroid. Now, let's say the top of the stack was 10 and the incoming value was -5. We need to make sure that one, we get rid of that negative sign. So we have to always make sure to do a negative of the asteroid and then compare. So now 10, for instance, would be greater than 5. And what do we do in that case? We know that if a value in the stack is greater than the value that is incoming, then you disregard the incoming value and instead you just keep the value at the top of the stack. So we just break out of this because we don't care about that incoming value anymore and move on to the next asteroid that's coming in. And the last case is where you're again looking at the value at the top of the stack, but that value is less than the negative of the asteroid. And this is an example when, let's say, you have 5 in the stack, at the top of the stack, and an incoming value of -10, for instance. One, you need to do a negative for that value, but then when you compare, you know that you should pop the value at the top of the stack and insert the incoming value. But we did mention that instead of inserting, we can just go on to the next iteration of this while loop and then just check if the next value in the stack is meeting the conditions, and if it's not, then you do any sort of work to fix that issue. So here we would just pop the top of the stack, right? Because the value is less than the incoming value, and instead of breaking now, we just do a continue. And this just means that it will move on to the next value. It'll redo this while loop and check if the condition meets for the -1, which is the new -1 since we got rid of the previous one. Now at the end of this, we do want to return our stack because they're looking at a return statement with a list, and that should be it. So let's run our code. Yep, and just submit it.